File Transfer Protocol, or FTP, has been used to transfer files since 1971. FTP relies on TCP for reliable delivery. FTP is great for plain text transmissions, but can also use TLS or SSL to encrypt the sessions. FTP can run in either active or passive modes. In both modes, the session is initiated on TCP port 21. In active mode, the client will inform the server on what port the server should access the client at. The server will then initiate a connection to the client from TCP port 20 for the data transfer. In most situations, a client's machine will be behind a firewall or utilize a software firewall which will prevent incoming connections. If this is the case, passive mode should be used. In passive mode, the server provides a specific port for the client to connect to. The client then initiates the outbound connection to the server for data transfer. Trivial File Transport Protocol, or TFTP, is a light transfer protocol. Its nature is perfect for devices that pull their configuration on boot or as a service for network hardware to transfer firmware and configurations. It's used by IP phones, routers, switches, and many smaller devices attached to networks. TFTP utilizes UDP port 69, so it is a connectionless service. Being that it's a light protocol, it can't list, rename, delete files, or directories. It also doesn't support any form of authentication. By default, files are transferred at 512-byte blocks, but the protocol can negotiate a larger block size. Each block is transferred in a single packet. After each block, an acknowledgement is sent back. If there is no acknowledgement, then the packet is retransmitted. Modern file sharing services and systems via a browser have all but killed the need for dedicated FTP servers. When a user is in a remote area and just needs to transfer a file somewhere else, it can still be an invaluable resource. Server Message Block is an application layer protocol for sharing files, printers, and serial ports. It can run directly on TCP port 445, which is how it's most often used. It can also run on legacy NetBIOS, but is seldom seen doing so. It's best known as the mechanism behind Windows file sharing. SNMP 2.0 was released in 2006 with Windows Vista. The supposed chattiness of the protocol was reduced. They took the volume of commands from over 100 to just 19. Multiple commands can be submitted in a single request, further increasing efficiencies. The block size was also increased from 16-bit to 128-bit in some cases, which improves performance in large file transfers. SNMP 2.1 was introduced with Windows 7 and Server 2008 RC2. This brought some performance enhancements. SNMP 3 shipped with Windows 8 and Windows Server 2012. This too saw additional performance boosts, as well as some new functionality. Additional security enhancements were seen, including end-to-end encryption was also introduced using AES signing. SNMP 3.1.1 was introduced with Windows 10 and Windows Server 2016. Additional encryption support was added, and it also implements a pre-authentication integrity check. If it determines that a client is SNMP 2 or greater, it makes secure negotiations mandatory. There's also an open source implementation known as Samba. This allows Linux devices to act as both SNMP clients and servers. And in some instances, they can even operate as a Windows domain controller. Virtually every network or system admin will use or facilitate the use of SNMP sharing, as sharing is one of the main advantages of any network. Secure Shell is a protocol to allow encrypted remote console access over a network. This is most closely associated with connecting to a Linux server, router, or switch for configuration. It uses TCP port 22 for reliable delivery of packets. Though it is most closely associated with Linux servers, Microsoft announced in 2015 that moving forward, Windows Server will have native support for SSH. It was originally designed to be a secure replacement for plaintext methods like Telnet. SSH uses public key cryptography via certificates to verify remote computers. A public or private certificate can be generated and installed, or, as is most often the case, the server will just generate its own certificate. Authentication of usernames is often done via accounts on the server being logged into or via a centralized authentication system for better control. Beyond remote access, SSH has some additional features. It supports tunneling, which allows you to securely send traffic over an SSH session. An admin can securely transfer files using SSH file transfer, more often known as SFTP. While SSH is native to most systems, additional programs are often necessary on a Windows machine. PuTTY is an open-source SSH client that also supports SSH tunneling. WinSCP is also open source and provides SFTP access. Version 1 of SSH was released in 1995. It was released as freeware initially and eventually evolved into a pay-to-play proprietary system. In 1999, developers took the most recent open-source version of SSH and began to develop and improve it. This project became known as OpenSSH and is still the widest deployment footprint of any open-source SSH implementation. Version 2 is, unfortunately, incompatible with SSH version 1. It boasts both security and feature improvements. It's likely the bulk of your network configuration and server administration will be via this protocol, so it's best to familiarize yourself with it now. Remote Desktop Protocol was developed by Microsoft to provide a graphical terminal for a remotely connected client. This functionality is also known as a terminal server or terminal services. It listens for connections on TCP port 3389. In essence, RDP allows a client to connect to a server through a software interface. This user is presented with what looks like a complete desktop through this application. It can also run in application mode, which loads a shortcut from the user's desktop and appears as if it's a standard application, when in reality, it's an RDP session established from the server. Every version of Windows since Windows XP has a copy of the RDP client installed. A version of the RDP server was introduced into Windows XP versions, save for Home, to act as a remote administration portal. Terminal services have been available on Windows Server since Windows NT 4 Terminal Server Edition. Standard Windows servers since 2000 have included terminal services allowing two users to connect remotely for administrative purposes. The newest version supports a plethora of great features like 32-bit color, TLS 128-bit encryption using the RC4 algorithm, audio redirection, which allows audio to be processed remotely, then sent to the client, file system redirection, allowing local files to be used over the RDP session, printer redirection, which allows local printers to be used over a remote session, port redirection for use of local ports over the remote session, clipboard sharing. Terminal services gateways now allow a client to connect via TCP port 443 to an IIS server. This will proxy a client to an internal terminal server. Bandwidth tuning for WAN connectivity, multiple monitor support, and Remote FX was introduced in Windows Server 2008 R2 SP1 to include virtualized GPU support. Like most popular software packages, there are open source versions for non-Windows operating systems like Linux and Mac. This covers both client and server versions. More and more enterprises are moving to a thin client model. Browser-based clients are starting to gain in popularity. This prevents an admin from having to install any client software at all. More and more enterprises are moving to a thin client model. This means users connect via lightweight terminals from their remote office to a central server. This central terminal server is usually co-located in a data center. Data centers generally have redundant power as well as redundant connectivity, which will provide a higher level of reliability for end clients. Centralized servers can also lower the administrative burden for sysadmins. Instead of having to maintain multiple desktop PCs, they only have to facilitate updates on a handful of servers. Also, the thin clients usually cost less than a traditional PC and don't need to be cycled out at regular intervals. RDP is key to many enterprises, and now you should have a few solid ideas why. The Simple Network Management Protocol is integral to every enterprise. It allows network admins to gather statistical information from network-connected devices. Workstations, servers, firewalls, routers, switches, printers, virtually any network-connected device. SNMP is heavily used by network management systems, or NMSs, that poll, trend, and alert on network and server status. In the SNMP environment, the server doing collections is known as the manager. The manager will generally directly run a network management station. This is the software package responsible for doing collection and storage. Some larger designs will distribute polling engines in geographic areas. A polling engine is a piece of software that will issue SNMP requests to manage devices agents. An agent is a software package that will respond to SNMP requests from managers. In short, the agent runs on the device you want to monitor. SNMP can be either read-only or read-write. Read is the ability to only retrieve information. Read-write gives you the ability to change information on a remote device. Writing can be used to adjust informational data, or do things like disable or enable switch ports. Whenever an SNMP agent is going to be polled, the information is retrieved by asking for specific object identifiers, or OIDs. OIDs are long streams of numbers in dotted notation. For example, the OID for system description is 1.3.6.1.2.1.1.1. Think of this like an index. Management Information Bases, or MIBs, will take these OIDs and map them to a hierarchical human-readable form. MIBs aren't always necessary for SNMP's function, but it makes it much easier to utilize. MIBs generally make it easier to add new monitoring points into an existing network monitoring system. Agents' requests are received on UDP port 161. SNMP traps are sent to UDP port 162. Traps are messages that are sent from an agent to a manager when some defined event occurs. When using TLS for encryption, an agent listens on UDP port 10161, and traps are sent on UDP 10162. SNMP version 1 and version 2C both implement a simple community-based authentication system. A community is basically just a plain text password sent to an agent. In version 3, there were 3 main additions: confidentiality by encrypting packets, integrity to ensure packets haven't been tampered with, and authentication to validate the source. Having a solid NMS is core to administrator sanity. SNMP allows an administrator to see trends. Predict issues, and react with speed and confidence. Dynamic Host Configuration Protocol is the de facto system for automatically assigning an IP address to a host. When a client wants to request an IP, it broadcasts a discovery packet to UDP port 67. When a DHCP server responds to the DHCP discovery packet, it will send a client a DHCP offer message to the client's MAC address containing the IP offer to the client, subnet mask, lease duration, and the IP address of the DHCP server. Server responses are directed to the client on UDP port 68. The client will now respond with a DHCP request message requesting the offered address. Last, the server will send a DHCP ACK message back to the client. The packet will include the lease duration and any requested information. The process is now complete. The DHCP server will be configured with a pool for each different segment of the network. A pool is a range of IP addresses to assign to users. A DHCP server can also assign each segment its own default gateway, DNS servers, and possibly other options. A DHCP server need not be directly connected to a segment. Routers can be configured with a DHCP relay feature whereby the requests will be forwarded over to a centralized DHCP server for processing. This is frequently used in a Windows domain. An unauthorized DHCP server can cause havoc on a network. These are known as rogue DHCP servers. They often result from users plugging wireless routers into the network backwards. They then start handing out addresses on the network, providing a false path to the gateway and ultimately orphaning clients. DHCP is, in essence, a foot race. Generally, whichever server answers first wins, so an admin can never quite predict which clients will be affected. A malicious user can also introduce a rogue DHCP server on a network to perform man-in-the-middle attacks. This can be mitigated via a couple of methods. Many switches support a feature known as DHCP snooping. Depending on manufacturer, only designated ports are allowed to act as a DHCP server. It generally builds a table of users' MACs and IPs which are requested on a user's port. Another method is to filter user ports from being able to send packets to destination UDP port 68. It's not the most elegant method, but it is effective. DHCP starvation attacks are also possible. DHCP pools have a finite amount of addresses available. If a single client connects, requests, accepts an IP, then changes MAC addresses and repeats, it will eventually exhaust all available addresses. Any new clients that attempt to connect will be denied an IP and thus fail to join the network. To mitigate this, the concept of port security is employed. This allows you to set a finite amount of MAC addresses that can appear on a single port. This number is usually set somewhere around 10, which is more than enough for common configurations. DHCP is a protocol you will encounter daily. Now you can better understand and protect your DHCP configurations.